All right, so now we want to talk about geometric series. So we talked about arithmetic series, and geometric series are very similar, but we want to try to figure out what is the formula for a geometric series. And what is interesting with geometric series is they are a little bit different because they don't jump by a common difference. So when you add them up, the terms get much bigger, much more quickly. So you can't go like 2 and 32 is 34, 16 and 4 is 20. So that doesn't really work. So we have to think, okay, well, what is the way we can develop a formula for this? Okay, because we don't want to have to actually write out all 10 terms of this sequence, which is what it's asking us to do, right? Find the sum of the first 10 terms. We don't have to write out, there's only 5 there, so we have to go 64, then 128, then 256, and so on. And we don't want to have to do that. So we're going to think about this for a second in terms of a geometric series. It looks like this. Actually, this is a sequence, right? But imagine this is my series. So I'm going to add them up, and it's A, and then AR, and then AR squared, and then AR cubed, and then AR to the fourth, all the way up to AR to the n minus 1, right? That would be the series. That would be what the terms were. And then imagine for a minute that I just multiplied this whole thing by R. And you might be saying, well, why would you arbitrarily multiply by R? Well, I'll show you in a minute. But we're going to multiply both sides of this equation by R. So we get R S to the n, not S to the n, sorry, Sn, and then AR plus AR squared plus, I just basically added 1 to each of the terms. Okay? You with me so far, hopefully? So then what we're going to do is we're going to take the sum Sn is AR squared, AR cubed, AR to the fourth, and so on, all the way up to AR to the n minus 1. The sum that we just found, we multiplied by R, we multiplied Sn by R, was AR squared, AR cubed, AR to the fourth, all the way up to AR to the n. And you'll notice, hopefully, that all of these terms in here are actually the same. So all I'm going to do is I'm going to subtract these two things. And if I subtract them on this side, I get Sn minus Rsn. And on this side, because these are all the same, they all cancel. So the only thing that's left is A and AR to the n. Now, I want Sn. That's what I'm trying to solve for. So I get Sn, if I factor it out of here, I get 1 minus R left. And over here, I can factor out an A because it's in both terms. And I get A onto 1 minus R to the n. And then all I have to do is divide by 1 minus R. So there's my formula. Okay, and you will see sometimes this written just slightly differently as A onto R to the n minus 1 over R minus 1. That is sometimes written like that instead. But it means the same thing, and it comes from the same derivation. It's just a matter of whether you subtract R, Sn, and Sn or the other way around. So that's the formula. So if I want to go back to my example for a second, way at the beginning, the original question said that find the first 10 terms, sum of the first 10 terms of this sequence. And we jump back here just for a second. So the first term is 2, and the common ratio is also 2. All right, so we're going to jump back here now, and we're going to try to plug in to our formula. First term is 2, 1 minus 2 to the 10th, and then it's divided by 1 minus 2. So then I got to go, okay, that's 2 times 1 minus, you got to figure out what 2 to the 10th is. So we can take our calculators, if you don't know right away, which is fine if you don't, and just go 2 to the 10th. Let me grab a calculator here to show you that. If it loads up, there we go. So we're going to go 2 raised to the 10th power. Oh, no, we're not. Just a second. I used the wrong button. 2 raised to, there we go, the 10th power is 1,024. So we go 1 minus 1,024. And then on the bottom, 1 minus 2 is minus 1. So then I get 2 times minus 1,023 divided by minus 1. So that gives me 2 times 1,023 because those minuses cancel. Excuse me. And that's 2,046. So that's how you use the arithmetic sequence and the geometric sequence now to produce an arithmetic series and a geometric series. So now we have formulas that will allow us to do anything with arithmetic and geometric sequences and anything to do with arithmetic and geometric series. Okay, now the arithmetic ones you could do a little bit more with, the geometric ones not as much. It's just basically finding terms. But if you look at this, it says find the sum of the series. So the first thing you have to decide when you look at this is it arithmetic or geometric? And if you notice, you're just multiplying by -2, right? You're multiplying by -2 to get -6. And then if you times by -2 again, you get 12. And then if you times by -2 again, you get -24. So the common ratio, it is a common ratio, first of all, and it's -2. And then the first term is 3. So our Tn is 3. And then -2 to the n minus 1. So then we got to figure out how many terms are there in the series. Okay, so that comes from some of the work you were doing with sequences by saying 192 is 3 onto -2 to the n minus 1. And then we say, okay, well, how do I solve for n? And there's really two options. One is you got to divide by 3 either way. So let's divide by 3, and that gives me 6 and then 4. So 64 is -2 to the n minus 1. Okay, and then you got to figure out what is the power. So -2 to what power is 64? And the answer is 6. Okay, if you raise -2 to the 6th power, you'll get 64. So that means that 6 is n minus 1, which means that 7 is n. So there's 7 n. There's 7 terms in the sequence. I said there were 2 ways to do this. The other way is to say use log. So you can go log of 64 is n minus 1. You're allowed to bring the exponent down when you do the laws of logarithms. So you can go log of -2. Okay, and then you do log 64 divided by log of -2 is equal to n minus 1, and then you can solve. The only issue that you're going to run into is if you take the log of -2, it's not going to work. So if I take my calculator and I type in -2 and then I hit log, it's going to say no, invalid input. The reason it's saying that is because you can't take the log of a negative number. So technically, that needs to be an absolute value. Okay, so what you do is you ignore this sign. All right, you just say that's not there for now, and use log 2, and then it will work. So if you go 64 log, okay, and we divide that by the log of 2, we'll get 6. Okay, so either way, you end up here. The only thing is, you might say, well, you can't just ignore the negative. No, you can't, but you ignore it for now. You take the absolute value of it for the logarithm, and then afterwards, you just check to make sure that -2 to the 6th power is 64. Okay, on your calculator, you can just check that. And because you know it is positive, because minus to an even power makes it positive. So that's going to work. All right, and then we get 7 is what n is. So then we say, well, what's the sum of the series now? Well, now we know that the 7th term is what we're looking for. Our first term was 3. And then it's 1 minus -2 to the 7th. And then divided by 1 minus -2. Okay? So we say, okay, well, that means we have 3 times 1 minus, and then -2 to the 7th is going to be -128. And then on the bottom, we get 1 minus -2, which is 3. So what happens is we get 129 because these 3's cancel, and I have 1 plus 128 because there's 2 negatives. So the answer is 129. That's what the sum of that series is. Okay, so that's how you do geometric series. Very similar to an arithmetic series. It's just that the equation is a little bit different. But then you can actually apply this to different things. So you can apply this to things like interest. How much money am I going to have after a while? All right. Or you can do, what if I want to retire as a millionaire? How much should I invest? That kind of thing. And so we're going to talk more about those later. But for right now, I think we'll just stick to trying some of the questions that are in the sheets that I gave you. The only thing is, I want to mention before we do that, we'll look at the word problem, the application problems later. We'll do that as a separate thing. We'll talk about the money problems and other problems that you can do. But imagine for a moment that you wanted to know what's the sum of all of the terms in a series. So instead of just saying, well, what's the sum of the first 5 or the first 10 or the first 12, what's the sum of all of them? And to do that, you have to think about whether or not the series is going to converge. So what does it mean, converging and diverging? What it means is the sequence getting bigger and bigger and bigger, and so therefore the series getting closer and closer to some number, or is the sequence just getting bigger and bigger? In other words, is every term bigger than the last one or smaller than the last one? So it's just going to get progressively smaller, meaning more and more negative, or progressively bigger, meaning more and more positive. And what you have to think about is looking at the partial sums, that is the sum of just the first term, and then the sum of just the first 2, and then the sum of the first 3 as a series in itself. And you essentially just look at and see, are those partial sums going to become infinite? In other words, as I add these up, S1 and then S2 and then S3 and then S4, are they getting progressively bigger or progressively smaller? Or are they just going to actually get closer and closer to a value? That's what the concept of diverging means. You're just going out to infinity. The concept of converging means that it's getting closer and closer to something, that it's narrowing in on some value. All right. If we want to determine if any series converges, we have to evaluate the limit as it brings us infinity. Okay. Now you might not know anything about limits. If you don't know what a limit is, then that's fine, because what we're going to basically do is say, instead of worrying about all of that, which we can do if you understand limits, we're just going to say this. Because we're only looking at arithmetic and geometric sequences and series, then here's the rule of thumb. If it's arithmetic, it just diverges. It gets bigger and bigger and bigger because you're just adding a number every time, or it gets smaller and smaller and smaller, but bigger in the negative sense. And so then it's always going to diverge. So if it's an arithmetic series and a question says, tell me whether the series diverges or converges, you just know it's arithmetic, it diverges. If it's geometric, you have to look at the R value. And you have to look at the R value because if the R value is between -1 and 1, in other words, it's smaller than 1 in either direction, then the series will converge, because you're going to basically be adding progressively smaller values. Okay, and if it's any other geometric series other than that, it will diverge. So if a question says, or somebody says to you, what's the sum of all the terms in a series, and they give you a series, the first question you have to ask is it arithmetic or geometric? If it's arithmetic, it diverges, so you're done. If it's geometric, then you have to decide, is the R value a value that's smaller than 1, a magnitude that's smaller than 1, so whether it's smaller than 1 or bigger than -1. Then if it is, then we know it converges. And it converges to this. Okay, and I'm not going to show you why it does that, because in terms of limits, because I'm not sure that you all have studied limits or know limits. But if you're interested in doing that, you can just imagine that R to the, if you take something that's really 1 over a number that's bigger than 1, so let's say 1/2, just for sake of argument, and I raise that to a big power, let's say 250, then I'm going to get 1 over 2 to the 250th power. That's going to be 1 over a huge number, right? And so what's going to happen is that's essentially going to be 0. And so if you imagine in your formula, it's 1 minus r to the n. If n gets really, really big and r is a fraction like 1/2, this term basically just disappears. And that's why the whole top just becomes 1 minus 0 is just 1. So this whole thing disappears and you just have a in your formula. All right, that's a very casual proof of that. So if you don't understand that or you don't really care about that, then that's fine. But you just have to know that the arithmetic series diverge and geometric series converge to this if they converge with r being between 1 and minus 1 and otherwise diverge. All right, so let's just look at an example. So let's imagine this one. First of all, it says you have to figure out if it converges or diverges, and then if it converges, figure out what it converges to. So first thing I look at, and this is the first type of question where the answer is not in the context of an arithmetic sequence or a geometric sequence. So you've got to first of all determine what type of sequence are we talking about. So this sequence is going up by 1. You can see that there's a difference of 1. So that means it's arithmetic because it's got a common difference. And because it's arithmetic, it diverges. So we're done. We don't have to do anything with that. Okay? This guy, you can tell you're multiplying by 1/2, right? You're timesing it by 1/2 to get to the next term, and then you're timesing by 1/2 again to get to from 1/2 to 1/4, and then you're timesing it by 1/2 to get to 1/8. So this is geometric. So then we have to say, is r less than 1? So we're checking, is r between 1 and minus 1? And we say yes, r is 1/2. So because r is 1/2, then we know it converges because it does satisfy this domain. And because it converges, we can then say that the infinite sum it converges to is a, which is 1, divided by 1 minus 1/2. Okay, because r is 1/2. So that gives me 1 divided by 1/2, and that is 2. So it converges to 2. All right. And then the third one, if you look at this example, this guy, again, the common ratio you can see is 1/3. You're multiplying by 1/3, and then you're multiplying by 1/3. So by the same token here, it's geometric with an r between 1 and minus 1, so it converges. And then what it converges to is a, which is 2 divided by 1 minus 1/3. So that gives you 2 divided by 2/3. And if you then invert and multiply, you end up with an answer of 3. So that's going to converge, that sum is going to converge to 3. And then this guy, it's geometric, but you're multiplying by 2, which means r is bigger than 1, right? So it's geometric with r bigger than 1. And if it's geometric with an r that's bigger than 1, we say it diverges. All right? So that's the idea behind converging and diverging series. And then if you look at it in sigma notation, right, you'll notice that you can gather the a onto r to the n minus 1 from this Tn. So if you look in here, right, this is your a and this is your r. So we go, the infinite sum is a, which is 0.2, divided by 1 minus r, which is 0.4. So we get 0.2 divided by 0.6. Okay, and then we can take your calculator and go 0.2 divided by 0.6 and get 0.333 repeating, or you can recognize, hopefully, that as 1/3. You can recognize it here because it's 2 over 6, really, right? Which is 1/3. So that will converge to 1/3. If you look at this guy, it's the same idea. There's my a, there's my r. My r is less than 1, but greater than minus 1. So we just go, it's a, which is 1.1, divided by 1 minus r, which is 1/3. So we get 1.1 divided by 2/3, which is 1.1 multiplied by 3 over 2. And if we just take our calculator and go 1.1 times 1.5, be 1.65. All right, so my answer here is 1.65. So that's the concept of converging and diverging. And you're just going to practice questions with that as well. We'll talk about the application problems with money and other things in the next video.